Hi, my name is Tien-Yin Chou. I'm the Dean of College of Construction and Development in Feng University. Welcome you to join our International Smart City e-Forum. Because of the COVID-19 pandemic, we have to change the entire forum into a kind of virtual one. But still, we welcome you to enjoy our speeches. In this speech arrangement, we have 9 speakers came from different countries and talk about different aspects regarding to the smart cities issues. 3 of them from Japan, Korea, and Vietnam. Another 3 is from the local and central government in Taiwan. And also, the last 3 is from the Feng University. The 9 speeches all regarding to the technology and the application by the smart cities issues. So hope you enjoy the e-forum, and please, if you have any question, you can simultaneously or after this forum, we'll put the entire video information in the website. You can always easy access to the website and also ask any question. So thank you again for your joining with us for this International Smart City e-Forum. Thank you.
Okay, so first of all, I'd like to appreciate for inviting me to this event and your leadership of this Asian Forum so long time. Anyway, I'd like to give a present. So I'm Ki-Joune Li, working at Pusan National University as a professor and also Dean of IT and Biomedical Engineering College. So today I will give a presentation on the policy of smart city in Korea, which is led by LH. LH stands for Land and Housing Corporation, which is one of the biggest national company in Korea. So they take care of the city development and urban planning and so on. So I'm not working for LH, but I have been working as a consultant for LH a long time ago. So I'd like to give a very short presentation on the history of smart city. So my presentation is not a very technical one. This is a kind of a general introduction of the history of smart city in Korea. All right. So this is the slide that I received from LH. This is quite a beautiful slide. Anyway, I'd like to start from the history of the smart city or urbanization in Korea. As you know, so the urbanization in Korea starts from the Korean War, which took place in 1950. So the Korean War was a very tragic event, but we may took advantage of this event that we can build the city from nothing. So we don't need to care of, for example, how to preserve the old monument or the cities and so on. So there is almost nothing, so we can design as we want. So that was a good things of that period. So according to the development of our industry from 1960s and 1970s, we smoothly start the urbanization because the many people left the company to cities, so we need a big city. So we try to build a kind of the apartment area or small scale cities from 1980s, and then we really start the urbanization or urban planning from 1990s. So which is the first generation. Then according to the development of IT technology like ubiquitous computing environment and so on, we really started the second generation of urbanization. So this is very beginning of the urbanization in 1960s, and then 1970s. So we little by little built a small apartment, and one of the main driver of this kind of urbanization has been LH, so which is really good and the main player of this urbanization and smart cities. And from 1980s, we initiate a little bit bigger sized urban development. Then the real urbanization or city planning took place from 1990s. It is not only in Seoul metropolitan cities, but also around the Seoul metropolitan cities. So, for example, here in Ilsan, which is very close to Seoul, this is entirely a new city. So we built the completely new town. So this is the beginning of real smart city. So one of the big difference between smart city in Korea and smart cities in Europe or other countries. So we built really from nothing for smart city. So we may construct every kind of infrastructure from almost nothing. So from the field of rice, for example. Then, and 2000, which is the beginning of the second generation of new town or urbanization, we introduced the IT technology like ubiquitous cities to build more better environment for life. Then this is so we come to the era of smart cities in Korea. So from 2003, we started the Ubiquitous City project, and the LH was the main driver, main player of that project. And from 2008, we tried to realize the real environment of smart city, covering, for example, the transportation and the environment, some place where we can experience the smart city technology and so on. So the concept of the smart city is, as I mentioned, it is to combine the IT technology with the several other requirements like the water management, transportation, and administration, and so on, public safety and housing. So this is the slide that shows the integration of IT technology and the new town planning. And this slide shows what's going on in Korea in terms of smart city project. There are many projects in Korea. So 73 cities in Korea, they are doing some smart city project. But I'd like to explain a little bit two cases. Here, I'm sorry that this is written in Korean. So it is called Sejong, which is a kind of a city where the complex of administration of central government is located. So this is a small city, but this is a really important city in Korea. And the LH is taking care of the smart city project in Sejong City. And another one is Busan, where I'm living. So here, because there is a big river around Busan, and so we call it the smart city project at Eco Delta City Planning. So this is to consider the natural environment and ecological the aspect of a smart city. So the goal is a little bit different. So the the goal of Pusan Eco Data City is the kind of ecological viewpoint, but the Sejong is to provide more comfortable city environment. So Sejong is led by LH, and Pusan Eco Data City is led by LX. These LH and LX are the key members of OGC from Korea as well. All right, so I would like to give a more detailed explanation about the Sejong use the smart city project. So okay, so the other one is Pangyo, which is very close to Seoul, and this is also one of the important use case of the smart city. So this is also led by LH. So we try to implement, for example, the real traffic control and parking to detect the illegal parking environment and so on, and also provide the health care and so on. And as I told you, so Sejong is one of the big ambitious projects. So this is entirely the planned city. We try to implement this the smart city project. So this Sejong city is still under construction. So some part of Sejong is we have also buildings and complex for the government, but some of the part it is under construction. So we try to reflect the very the high technology for smart city. So this is the overall the picture, and of course we build the 3D city modeling in CityGML covering this the Sejong city. So, and for some important public place in Sejong, we are building the data in IndoGML. All right, so these are the main feature of the smart city project in Sejong. Like so as I told you, some area of the Sejong is under construction. So before constructing the road, for example, or the building, so we can first apply some kind of simulation based on the smart city or digital twin cities, and we introduce a CCTV monitoring system and analyzing sunlight and landscape analysis. And finally, the goal is to provide a digital twin. That means on one hand we have the reality with some augmentation, and on the other hand we have the synchronized world from the real world to the virtual space. All right, and Dongtan is also a city where LH is planning for smart city. So this is the main feature of the Dongtan city. So this is also very close to Seoul. All right, and beside the domestic planning, LH is trying to collaborate with the foreign countries. So we have some they have some connection and collaboration, for example, Abdullah New Town or some other cities in Middle East. And also in terms of this internal collaboration, they launched OGC pilot project for 3D IoT. So they provide some legal foundation, and we also introduced some certification system of the smart cities and smart city services, and we built also some innovation space for incubating the industry. And we also support some R&D project to develop the high-tech technology. All right. Okay, so this is briefly the mission of the smart city from LH. Okay, that's it from my presentation. Right. So there is some place where you can experience the smart city technology. So if you are really interested in the smart city in Korea, particularly led by LH, then you may contact with LH or to me to have experience insight in some place in Korea. All right, that's all.
Okay, thank you, Professor Li. So I think once again, from the attendance participants, are there any questions for Professor Li?
First of all, I'd like to thank Professor Chou, Jimmy, for inviting me to this forum. And I'm very honored to make this presentation on behalf of our integrated team in 2 of our 8 national laboratories within the NARLabs. And the integrated team includes my colleagues from National Space Organization, NSPO, which builds the Formosat satellites, and also the National Center for High Performance Computing, the NCHC, which operates the HPC and the cloud computing facility in Taiwan. Next slide, please. And in recent years, Open Data Cube is being promoted by the CIOS, which is the Committee on Earth Observation Satellites, which provides a potential solution to facilitate various applications of multi-temporal and multi-sensor remote sensing data. And this solution has the advantages of easy management, high efficiency, and it shortens the time to decision making. Next. And Taiwan initiated the Taiwan Data Cube, and we started development in 2017 after a GEO meeting in New Mexico City. And this initiative in Taiwan is a domestic alliance of National Taiwan University and some research institutions in Taiwan. And we had general support from Australia, the CSIRO. And after building a prototype, we engaged in Global Forest Observation Initiative, which is short for the GFOI, with the first application in forest management. And then we injected Taiwan's Formosat satellite imagery. And just last year, in 2020, we completed the trial operation. And that was followed by recent launch of the TWDC in the normal operation phase from January of this year. Thank you. Next page. And the NARLabs has built a TWDC that contains the imagery from Taiwan and the United States and European satellites. And analysis-ready data of the Formosat is generated into this data cube, while the infrastructure is supported by Taiwan Computing Cloud, TWCC of NCHC. And the performance of this TWDC is thus enhanced by the capacity of the HPC Taiwan Near 2. And that has the speed of 9 petaflops. Next, please. And another feature for this TWDC is the multi-cube service framework. We have created the framework across various cubes to promote the effective networking from different satellite sources, and also further accelerate the cooperation, the operability, and experience sharing between the data providers and the users. Based on the Taiwan Data Cube's service system, Earth observation applications can be extended to across many disciplines. And the cubes can be either public or private and also can be either free of charge or non-free. Next chart, please. And currently, TWDC is capable to conduct integrated cloud analysis, which means users are able to drive the TWDC on the TWCC cloud from local platform, which users are familiar with, to conduct required analysis, and then display the analysis results locally. In this specific case of NCDR, which is the National Center for Disaster Reduction Technologies, they select to use Data Cube and select the product type and sets up the parameters via QGIS. When the analysis is complete in cloud, the analysis results is automated to display at the local user end. Through this TWDC integrated cloud analysis, efficiency could be further enhanced. Next. And this TWDC has attracted nearly 20 teams to join in our trial operation phase. They are from the government, academia, research institutions, and some private companies. Applications covers detection in agriculture, water quality, marine environment monitoring, land use classification, forest wildfire, and etc. These applications are aligned to the universal values today, which is the UN SDGs, climate actions, Sendai framework for the DRR. Next chart. And these applications are aligned to these universal values. And it is also noticed that these practices are implemented in Taiwan and overseas too. It has free of charge, but users are obligated to provide their feedbacks as a means to improve the system. I will use two examples as a showcase. Next slide. Next, please. No, the previous one. The application in DRR, yes. For the disaster risk reduction, this example shows you a flood module that we have developed, which is developed to demonstrate the efficiency in emergency disaster response practice. In normal operation of spaceborne emergency service platforms such as Sentinel-Asia, the time between emergency observation request and the delivery of acquired images, along with an analyzed inundation map, is critical. In this example, floods occurred on August 26 in southern Taiwan in 2018. Because of extreme rainfall, the ARD of Sentinel-1 radar backscattering coefficient has been used to extract the flooding area. With the TWDC flood module, time for the EOR to results delivery can be considerably shortened. Next slide, please. This is the second example, which is an application for the paddy rice detection. And this chart shows the first application in this field. The joint research project in precision agriculture is being conducted with our partner in Thailand. Together, we are building a data cube in Thailand in agriculture and food security issues. And in this project, AI is being applied to monitor and analyze the distribution change of paddy rice in this region. And finally, I'd like to make a summary of my report. Next chart, please. The Taiwan Data Cube facilitates an efficient cloud computing platform in support for the multi-temporal analysis of satellite Earth observation images. And this platform will lower the technical barrier for users to exploit the power of data from the satellite, and hopefully from UAV too, with algorithms in various applications. And applications of TWDC can further provide substantial societal benefits to achieve the SDGs across the communities, including the government, research institutions, and academia, and also industries. Having said that, with advantages of this data cube, we would like to work with you to build international partnership. Thank you.
Okay, so thank you.
Thank you very much for having me here today. My name is Samuel. I'm from the Soil and Water Conservation Bureau. So today I'm going to share some experiences. The Bureau deal with landslide disasters in the past decades. So this slide shows the organization chart of the Soil and Water Conservation Bureau. Originally, we are the engineering unit. So we do a lot of engineering construction works in the mountain areas. And recently, we deal with the landslide debris flow disaster prevention works. We also have some rural village regeneration works we are doing. So we got several divisions and we got 6 branch offices around Taiwan. So from the right-hand side, you can see that over 70% of the land belongs to the slopeland. Besides, we have frequent typhoons and earthquakes. That's why we have a lot of sediment-related slopeland disasters every year. So here are some pictures and a video about the debris flow disasters, which is a kind of landslide. Those kind of debris flow disasters usually caused by different typhoons, which bring some torrential rains. And after the video was televised to the public in 1996, people here aware of the severity of debris flow disasters. So this slide shows the framework, how we deal with the debris flow disasters. Usually, when we are doing the hazard assessment about debris flow disasters, we will ask ourselves 3 questions: where, when, and how big. So where are the debris flows? After more than 10 years investigation in the field, we have more than 1,700 potential debris flow creeks, which means those creeks are prone to debris flow disasters. And each creek has the downstream affected area, which is usually the fan areas. People who live there were prone to debris flow disasters. So every year we work with the local government to come up with the inventory of those people who live there. It's about 50,000 people. So from the left-hand side, traditionally, we use a lot of engineering construction, try to prevent from happening about the debris flows. But then we found out that those kind of engineering construction has a limitation. So recently, the government turned to some software measures, such as the relocation of the local people, restriction of the land use, but people don't happy about that. They usually will protest against those measures because the price of the land will going down. So recently, for the government in Taiwan can do is that during the emergency when typhoon comes, we evacuate people to the safety shelters. So if we want to evacuate people, then we have to know when the debris flow will come. So before that, we have to set up some kind of rainfall-based early warning system to issue the warning for the evacuation of the local government as well as the local people. So every time during the emergency when typhoon comes, so we just establish the debris flow emergency operation task force in our bureau. So we have a web-based decision support system, which is a cooperation with Professor Zhou and Feng University. Then we received hundreds of the real-time rainfall data from different resources, such as the automatic rain gauges all around Taiwan, more than 500. And we set up some on-site monitoring stations, like the pictures you can see. From the right-hand side, we use different kinds of sensors to detect the occurrence of debris flow and issue the warning to the local people. We also try to train the local people and establish their community into so-called disaster-resistant communities. People are well organized. They know what to do. They know their jobs during the emergency. So those kind of communities has the right-hand side, the black one. It's a simplified rain gauge, which can detect the real-time rainfall and send back to our headquarters in our system. After calculation, then we issue the real-time warnings. We also work with the US, NOAA, and the Central Weather Bureau, Water Resources Agency. We assemble using different kinds of radar system to receive all kinds of reflection from the radar about the rainfall prediction. That's very important for us to issue the debris flow warnings. So from the warning stages about debris flows, usually we have two stages. When the predict rainfall is over the threshold in certain area, then we issue the yellow warning for persuasive evacuation. So when this area, the real rainfall is over the threshold, then we issue the red warning for the mandatory evacuation. So people just, according to the act, they have to follow this instruction to be evacuated by the local governments. So from 2004, we deployed this kind of debris flow disaster prevention system. And let's take a look at the red line, which is the debris flow casualties and wounded number versus the typhoon, the whole events. We find out after we deploy this kind of system about the evacuation plan and early warning system, the ratio is getting lower and lower, which means this kind of system has been proved effective about saving lives. But in 2009, we encountered another different kinds of landslides, not only debris flow, but deep city landslide. There's an event during the Typhoon Morak, which is the most devastating typhoon ever hit Taiwan. In southern part of Taiwan, a village called Xiaolin Village, when the deep city landslide occurred, it covered about half of the village and then formed a temporary dam. About 40 minutes later, the dam broke, and then the floods just flushed away the other half of the village and causing more than 450 casualties in one event. Those kind of events just shocked our whole countries. So after that, the Soil and Water Conservation Bureau tried to come up with a program which named Comprehensive Program of the Large-Scale Landslide Hazard Mitigation, under the climate change impact. So this year is 2021. So this is the second stage of our program to deal with the large-scale landslide. The total budget is about $400 million US, and we try to deal with at least 100 sites prone to large-scale landslides. From this picture, the left-hand side, you can see the Xiaolin village before the large-scale landslide. The right-hand side is after the large-scale landslide. Nothing left there. Everything is just flushed away. So this kind of program based on the identification of the potential areas prone to large-scale landslide. We use the LiDAR techniques try to solve this problem. The LiDAR techniques is the light detection and ranging. It is a very common ways to make the high resolution DEM, which is the digital elevation model. On the right-hand side, usually we use the airborne LiDAR. And from the left-hand side, the pictures, this LiDAR DEM can remove all the vegetation and reveal all the geological and geomorphic features about the deep city landslide, like the pictures in the center. So whenever we find out this kind of characteristics of the large-scale landslide, then we can zone it and, like the hazard mapping method, try to identify those areas prone to the disasters. So after that, we do the risk analysis. We consider different kinds of degrees, different kinds of indexes about the activity, about the people who live there, about the hydrological and the geological conditions, and we have our own priority about these potential areas. So we just put the money to different places through this priority about the engineering constructions or some evacuation plans, or try to train the local people become the resilient communities. We borrow our debris flow hazard mitigation experiences, try to put them into the field to solve the large-scale landslide. And we do a lot of different kinds of monitorings. Such as we use the INSAR techniques, which is the satellite radar reflection, try to detect the surface deformation, especially the minor deformation about the ground. So subsidence is the places we are trying to look at using the INSAR techniques. We also put different kinds of surface displacement monitoring system. For example, the GPS system, extensometer, we compare this displacement with the rainfall data, try to find out the behavior of the large-scale landslide. So from the left-hand side, we do some engineering construction. For example, the most commonly used engineering construction is the groundwater collection well. When we dig the well in the slope, then we collect the water of the underground, and from the red circle, after the well construction, the groundwater table just decreased a lot, which means the driving response and evacuation under limited bandwidths. We share our experiences dealing with the landslide, especially focus on the debris flow disasters. So in the future, we are willing to share more and more our experiences dealing with not only the debris flow, but also large-scale landslide or even the shallow landslides. We would like to experiences sharing about to those communities about OGC families. So we also like to learn some experiences from other communities. So we hope we can continue to devote ourselves to this community. That's the end of my talk. Thank you.
So hello everybody. So I'm Hung from Vietnam, and firstly I want to say thank you very much, Professor Tien-Yin Chou, to invite me to attend and have a presentation in this meeting. And my talk is very very beginning application of the CityGML standard. So we apply the CityGML standard to develop Vietnam National University Virtual Campus. It's just very beginning application. The motivation of the work is very simple. So we think the people who interested in working or studying in our university, Vietnam National University, may want to explore the campus before they actually come there. But there is no such an existing system, so we try to do it using OGC CityGML standard. And I think everybody here knows what is CityGML. It is a standard for data model and exchange format to store digital 3D models of city and landscape. And CityGML is for 3D features and objects in the city. And important, there are 5 levels of details in CityGML, as shown in the picture here. So the LOD 0, we only have the 2D footprint of the building in the city. And for the level 1, we have the height of the building. For level 2, we have the roof of the building. For the level 3, we have texture of the building, and for the highest level, levels 4, we have interior of the building. And for the related work, we can collect data from optical images such as satellite image, aerial images, and for the higher level, we can use LiDAR data. And for the method of the building the 3D city, we can use the stereo image triangulation or the uncalibrated structure from motion, we call SFM, or 3D construction algorithm from LiDAR data. And the objective of our work is we build the 3D model using the CityGML standard for our Vietnam National University campus. And this slide is about our methodology. We collect data from 3 sources. So firstly, we use the Google Earth and image. The second, some students go to the field, go to the campus, and using the optical cameras to take picture about the rooftop, the roof, the wall, and we collect data from the base maps also. And for the building boundary, we extract from the Google Earth image. For the roof information, we extract from the both Google Earth image and also the field image. And for the texture of the building, we extract from the film image and for the also from the base map. And at the next step, we have the building boundary. We have a roof type and structure of the roof. We have a texture of the wall of the building, and we also have a road layer of the campus. And students also go to the campus to take a picture, and we collect the 3 information in the building. And on the data, the 5 type of data we integrate to generate the 3D model. And we use the FME software to generate the 3 models of the data. And we use an open source software named Cesium. I think everybody knows. And we build some functions of the software, like the base map support, the visiting mode of the campus. We can search the building, information building. We can integrate the weather information to the campus, and we try to visualize all the information together. And this slide is how to collect data. And for the data we collect from the satellite image, we can you can see in the picture A, the building boundary can extract from the Google Earth satellite image. We can draw the building boundary, the footprint of the building. And the second number, the B picture, the roof edge can be extracted from the satellite image. And we use the road structure from the OpenStreetMap. And for the 3 information, the student have to go to the field, to the campus, and they take many pictures. And we, you can see in the picture, we have the table of the 3 distribution in the campus. And we have the 3 attributes, ID, the height, and so on. And for the texture of the building, students have to go to the campus to take many pictures on the picture of on the campus, and we extract the texture of the wall of the building. And here is a workflow. We collect the building boundary or footprint, so we collect the wall height, and also collect the construction of the wall surface, the texture. And we generate the building information model using the CityGML standard. And we also integrate the roof information to generate the building information using the CityGML standard. Finally, we have a roof boundary, roof height, roof edge, and roof types. And we use the FME software to generate the ground surface construction, the wall surface construction, and roof surface construction. And here is the roof type in the VNU campus. And finally, we integrate all the data using the CityGML standard and KML. And the data is input to Cesium software. And the software, we visualize, we integrate the weather information. We provide the visiting mode and search mode of the software. And let me show a short presentation of the campus. So we have a video highlight mode. So student can see the guideline of the Virtual campus here. And now they search. The keyword here is Vietnam National University, and the system navigate to the Vietnam National University, and you can see is the whole campus here. And this is the main gate of the campus. And now I turn off the video guidelines mode, and we start the visiting mode. And the white building is a conference hall of the campus, the main gate. When we can change the different kinds of base map for the system. And now we visit the campus. Now we visit. This is the main gate of the campus. You can see the building. You can see the tree, the road, the texture of the building, the name of the building, the tree along the street, the dormitory of the student, and we can show the building information like the name of building, and we click on the building, and it shows the name of the building, and the detailed information for each building, so how many level and functional room of each building. Yes, the building information is different by buildings. And we also integrate the weather information in this system. So now it is raining here, and you can see the cloud and the raindrop is go down. And we can also see the building change by time. So it's the morning, and we slide the time to the noon, and in the evening the campus become black. So we also integrate the time dimension in this Virtual campus. Yeah, that's it. So for conclusions, so this is a very beginning application of the CityGML for 3D cities done by us. So we collect data from satellite image, from whole Earth image, and also from the OpenStreetMap. And students also went to the campus to take many pictures to have the texture data of the building, and then we build a 3D system for the campus of Vietnam National University. So the limitation of this work is it requires a powerful hardware for the 3D model generation. And for future work, we will develop the campus, virtual campus, at higher level of detail. So in this step, we stop at the level of detail 2. So next step, we try to do with the level of detail 3 and 4. And we also try to develop the techniques for the automatically data generation focus to reduce cost when we try to do with the larger area and larger mode. Yeah, thank you very much for listening.
Okay.
From Taiwan, thanks Professor Zhou for inviting me to join this forum. And this is my topic, the development progress of 3D geospatial infrastructure in Taiwan. Next, please. So this is my agenda. I want to introduce the development progress of 3D GIS infrastructure. And the third is the application of geospatial technology in NCHC. And next, please. Okay, the National Center for High Performance Computing. The Taiwan is only one national level supercomputing center. The NCHC possesses a large computing and networking platform facility for use by domestic academy and the general public. Next, please. Our mission is enable scientific discovery and technical innovation through prosthetic computing technology and platform. We are the Taiwan AI HPC enabler. Next, please. So we established in 1991, and during 2016, we established 100 gigabyte network bandwidth, and 2017, we set up the Taiwan 1. The computing power is 1.49 petaflop. The next year, we built up Taiwan 2. It's for AI research. And 2019, we established AI platform. It's Taiwan Computing Cloud Platform. It can use for anyone to create a container and virtual environment to do their research or their application. And from now on, this year we start to build up Taiwan 3. This is 2.7 petaflop. It's double than Taiwan 1. Okay, next, please. This is the Taiwan 1, the capability. So everyone can see that. Please, next. The next is Taiwan 2. So this is NCHC is accelerating AI innovation in Taiwan. So we prepare the software and the AI framework for the user to training their data. Next, please. And this year we established Taiwan 3. This is for AI and HPC computing power. Next, please. And based on the high performance computing, we need to establish the high speed network bandwidth. So we set up Taiwan Advanced Research and Education Network. TARUN is about 100 network bandwidth. Next, please. We also try to analyze malware behavior. So we build up the malware behavior knowledge database and analyze the behavior. Next, please. So I want to introduce the development of process of 3D GIS infrastructure. Next. So the first problem of 3D GIS platform development, they have some critical issue, such as redundant investment and limited visibility on GIS software. The third is 3D data format incompatible and data silo and hard to maintain the hardware. So we try to establish the GIS platform as a service on the cloud. The next, please. The rise of cloud computing makes it easy to have a new platform that anyone can make flexible or simplicity of applications. National Center for High Performance Computing play a lead role in cloud technology that process large computing, storage, network, and platform integration. To provide the domestic user with GIS service, we built 3D GIS platform as a service that enable geospatial application easier with lower cost, automatic update, and information sharing. So we hope the public and private domain, they hold their data can collect on the private cloud and using federation to share their data. Also, they can using AI model to training their data and display on the 3D GIS platform. They are also based on NCHC infrastructure. Okay, next, please. Do the high-speed geomorphology analysis. So we can do more higher resolution DTM data to create all kinds of geomorphology value-added data and integrate to 3D GIS platform that makes user can easier access the data and display. Okay, next, please. This slide shows we also integrate smart flooding proofing system. The data collect the rainfall and inundation data using SWCB Taiwan 2 to simulate the flooding situation, and we collect rainfall and simulation data to make AI training data set. So we will create all kinds of flooding case based on the rainfall situation. So this data we can also integrate onto the GIS platform. Next, please. Okay, this is the flooding situation, you can see that the case is in Hsinchu city. Next, please. So we also integrate city IoT data with OGC sensor sync API. Based on sensor sync API, we create a high-level API to make the user can easily access the data on the GIS platform. Next, please. We also try to enhancement of generation 3D model. We integrate 3D model of real world with GIS platform using high-speed process. So we want to shorten the time of the rescue. So they can, on that platform, can make the UA drone image process 3D model more quickly. Next, please. Another case is we try to integrate raster data using raster data management. And this is the showcase. We integrate raster data management and we build up AI model. So we leverage two of them onto the GIS platform, make the analysis more easier. So you can see we can select the data and the category of image. So we process search, they will list all data within this bounding box more quickly, and we can process the AI model is more quickly and can let people download the share file data. Use they can bring to their QGIS and make another analysis. Okay, next, please. So our vision is we try to make 3D GIS fusion platform on the cloud that can make everyone with lower cost and easier to make applications and more easier to share information. We aim to become the first 3D GIS platform cloud service in Taiwan. Thank you, everyone.
My name is Kyung-Soo Kim. I'm a senior researcher, Artificial Intelligence Research Center in AIST in Japan. So I would like to introduce some of one of a project I am involved to related of the geospatial informations. So today, most of us we talking about the 3D. So actually, in the context of the digital twins, we believe of the 3D map or geo information is a fundamental element to realize that. And so map is representative of the what and where it exists. And why we need a 3D map. So I don't want to talk about more detail, but anyway, we think the 3D map is to provide more accurate locations, and based on the accurate locations, we can provide a safer and the more secure mobilities. For example, the features cases, if we cannot consider about the Z, and this we cannot support of their safety mobilities. Even the small, very small height of is tackled paving, but the future people, we heard the people on the future, they feel a little bit uncomfortable when they passed up this kind of blocks. So also we think if we created 3D maps, then we can develop the new generation of the geospatial map, such as the autonomous vehicle driving cars and robots, and also personal experience augmentation is not only the informations, and then also sustainable urban planning or disaster management. So those kind of new type of the geospatial services, we are very interested to create it of the 3D map informations. However, depending on the who is users, they need that different type of this 3D information, not only the geometric element, but also semantic features. For example, the car, they are mostly using the line strings element, but its drones, they are using the more pixelized map. And then also on the picture cases and also drone cases, they have different point of interest. Also, in this 3D map is not static informations. So in driving autonomous vehicles, they consider about local driving map to consider about the dynamic information from the sensor data, such as vehicles and people's movement. And then even indoor spaces, the traffic, pedestrian congestion map is helped to support of the efficient navigation or mobilities. But when we generated a 3D map from the large amount of low point 3D point cloud data or human mobility data obtained by the heterogeneous sensor devices, then we have the big issue to handle the big data. We face the big data problems. So it's depending on the volumes, and also there are different sensors. So we have to also consider the variety and the variability and velocity and velocities. So those kind of issues is we need to handle it to consider about the 3D map. And then also, it is very, too expensive to manage and then construct a comprehensive and the highly accurate 3D geospatial informations by considering all type of the utilization in advance. So basically, compared to the 2D map, I think still we have a very big problem. We have some big obstacle to create of the 3D environment on the virtual side. That is because of the cost. So how can we reduce this kind of cost, this kind of motivations? 3 years ago, our organization started the project. It's one of the NADO project. NADO is our funding agency. So this project is a 3D map platform to support a safe and secure mobilities to realize an ecosystem of the 3D map platform that provides satisfactory of the 3D data set for supporting the various mobile services. So we inside of our project, we have 3 types of applications. For example, the human flow and the transportations, and then also logistics. And then to support these 3 types of the applications, we created of the data platform. Also, we are focused on the localization or detection position of the and not only the external environment, but also internal environment. And also using the real spaces is such as the Odaiba and the Kashiawaha. This is the name of the place. And then we created of the real environment for our experiment. So I'm also reading of this special temporal data platforms. And then our platform we called point ML. So it's a place and time for the machine learning. So this platform we are consider about not only the static geospatial data, but also the dynamic geospatial data. So what is the static information is just like the wall or ceiling, those kind of, the buildings. informations is we consider about as the static informations. And then dynamic information is, for example, the people's movement is or robot movement. Those kind of informations we also manage of the inside of our platform. So the platform can accumulate it and manage this large amount of the real-time data of the moving pictures, such as the traveling vehicles data or flow of peoples, also analyzed to predict the congestion area given the time resolutions. And then our platform is quite big, have the big open software stacks. And then we support the two types of the API. One is the 3D API, map API, and the moving picture API. And then today I would like to show some demonstration of our applications. So first one is the autonomous vehicles environment. So this maybe I'm gonna change this. So in this April, we attended some exhibition. It's called the Location Business Power in Japan. And this robot is autonomous driving the robots. And then in here, so you can see that there is a LiDAR sensors. And that this sensor is detected of the people's pose, orientations, also locations, and then try to tracking of the people's movement. And then also here, there is another LiDARs, is also there, have the same functionalities. And then those data is go to our platform via the API. And then our platforms continuously process of the which area is have the more people is where is the people's there how to say crowded. So you can see there's some red yellow box and the red box. So we represented this area is have more people than other area, and the red box is represented is more than 5 people in this area. So this is the every 5 seconds they calculated of this kind of informations, and the platform accumulated of this information whole day, and the next day we make some deep learning model to predict of the conjunction informations. So in the next the left side, this information, this is kind of a prediction map of the conjunction using our deep model. So you can see that some strong colors is represented is the we perfectly estimate predict of the conjunction, and then some weak shell color is represented. This is still we mispredicted. But anyway, this platform is hybrid, is the continuous query and then also batch query. And then another example is the workflow analysis and then in various tool. And then this is the, I'm sorry for the, but this is the some warehouse information. And then we using the irregulars is picking information of the workers. We continuously generated of the movement information is like that. And then using the analyze the trajectory informations, we analyze of the which area people spend more time. So this graph represented of 3D, but this red color represented of the staying time. So you can see the which area is the workers, where the worker is spend more time than other place. So using this information, we can recommend of some optimization of the layout or scheduling of the pickings of the pickings. And then last demonstrations is the simulations. Using the simulation of the when we using the 3D map in the simulation, it is difficult to using the 3D point cloud data because of the volumes. So in usually simulation environment, they're using the vector information or certain GIS models. But how can we create it of the 3D GIS model from the point cloud data? So for example, we can we capture the 3D point cloud data using the mobile equipment. So this is a mock-up environment of the living place in our buildings, and then we collected of the point cloud data, and then I think the network is a little bit have problem. So this is the example of the capturing the point cloud data, and then using our platform, we voxelize of this point cloud data, and then make the clean point cloud, the subset of the point cloud data. And then using the subset of the cloud data, we can try semantic segmentations, like the wall, we can try to recognize of the wall and ceilings, floors. And then using the certain landsat algorithms, we created of the wall informations is like that. And then we can easily create a certain floor map information using our platforms. And then now we have the certain missions. How can we, it's not only work, how can we create it of the certain indoor model, GIS model? It's not only indoor but also the outdoor spaces. So currently we try to create it as a CityGML, or we have a plan to create generate it of the indoor GML. But anyway, so still we have a lot of the challenges to create it for the automatic generation, the 3D GIS model. So I'm very welcome to your collaborations or interested. So please feel free to contact me. So thank you for your attentions. I'm sorry I already did longer presentations.
Hello, my name is Tien-Yin Li from Department of Civil Engineering, Pusan University. The topic I'm presenting today is automating the generation of indoor network for human wayfinding using 3D GIS. In short, I'm going to introduce an algorithm that I propose to generate the indoor version of Google Maps. Most of you probably have the experience of getting lost, because the current indoor wayfindings for human beings is still highly artificial. For example, here's the floor plan provided by a shopping mall. It gives you a map and a long list of indoor spaces. Obviously, people still need to figure out their ways by themselves. Nowadays, public buildings may provide 3D map like this. It looks straightforward, much easier for humans to understand the indoor layout. But how about this one? For those buildings with complex structures, like Taipei Main Station, the static map, either 2D or 3D, is still not good enough for citizens in smart cities. What if we have an indoor version of Google Maps? You simply type in the origin and destination of your trip. The system automatically gives you the shortest path from point A to point B inside the building. Let's have a look at how Google Maps finds the shortest path. First of all, it requires a street map. More precisely, it is network dataset that store geometry and attribute for each segment of street. With the network dataset, the algorithm can calculate the shortest path in terms of distance and time. How about indoor environment such as buildings? Similarly, it requires indoor version of street map. For the past 15 years, 3D modeling technologies is quite mature. When you're modeling a building, you create the structural components like columns, beams, slabs, and walls, etc. You don't really create indoor paths like this. If you want to create indoor paths manually, it's gonna be time and energy consuming. And it's also very easy to make mistakes. So about 3 years ago, 2018, I proposed an algorithm called iGit to automatically generate the indoor path or the indoor version of Google Maps. The only input for the algorithm is the 3D model. It has to be in a standard format called RFC. There are 3 steps in the entire geoprocessing workflow: identifying indoor spaces, generating floor level path, and generating non-floor level path. Here's the example of indoor paths created by the algorithm. The upper right on this slide is the floor level path, and the rest of the slides are non-level paths, including stair path, ramp path, and elevator path. In following slides, I'm going to introduce the logic of algorithm to create those paths very briefly. Phase 1. Identification of indoor spaces. The algorithm first intersects the horizontal components like slab and vertical components like walls, columns, and doors to generate the partitioning areas of indoor spaces like this. Next, the algorithm cut the entire boundary of slab by partitioning areas to generate the indoor spaces. And the center of each indoor space will be the node that indoor path must go through. Phase 2. Generation of floor level paths. The algorithm then divides those indoor spaces into triangles using the Delaunay algorithm, and it connects the midpoint for each internal side of triangle to form the path for those indoor spaces with irregular shapes. And finally, the algorithm connects the endpoint of the paths created previously to the nearby doors to form the entire floor level path as shown in this slide. And phase 3, generation of non-level paths. This is the major part of innovation of iGit algorithm. The following innovation explains the complex logics of the algorithm to generate the stair path. The first version of algorithm only supports the stairs with straight flight, and the later versions of algorithm continue to support other two categories of stairs, including wider stairs and spiral stairs commonly seen in public buildings. As mentioned before, the indoor path is the key to the indoor version of Google Map. So here's the example of indoor paths created by iGet algorithm for high-speed rail Taichung Station to demonstrate the application of indoor paths. Here's the systems we created for the demonstration. The origin of the scenario is Taipei Main Station and destination is National Taichung Theater. The systems will give 3 suggested trips from origin to destination. All of them include high-speed rail and then take a bus. By clicking the high-speed rail icon, the systems will direct you to navigate the entire shortest path calculated by the system. You can navigate the path starting from you get off the train and down to the level of gate, and then take a route on your left hand side to exit the gate and continue to move forward to level 1, where you can take the bus. Other applications include campus direction systems in Pusan University. Similarly, you type in origin and destination of your trip, and the systems will calculate the shortest paths for you, including outdoor paths and indoor paths as well. Currently, the system can only make a route plan for you to reach your indoor destination. But in the future, if we have more mature indoor positioning devices like a GPS for outdoor, we can also do the real-time indoor navigation as we do with Google Maps for outdoors. So this is all my presentation today. Thank you for your listening.
Hello, I am Dr. Yi-Ming Huang, the Assistant Professor of the Department of Civil Engineering from Feng University. Today, I would like to share the study of inspection of hydraulic and slope stabilizing structures by using UAV and high-resolution thermal imaging. Today's presentation will start with the purposes. We will talk about the purpose of this test pilot project. Then we will spend more time talking about the sampling procedures and our first test run and its results. The purpose of this pilot study is try to find a way of using UAV with a thermal camera to help us non-destructive inspection, especially for the hydraulic and slope stabilizing structures. And we want to find a safe way to help our colleagues to do the jobs when we conduct the inspection at the remote areas. We can using UAV and the thermal images. So that is our major goal of this test pilot project. So In the following presentation, where I will share with you about our initial stage, the first test run results, and also the analysis from the images. These are our study areas. We choose the mountain area in the middle of Taiwan, and there are two villages, Nangang Village and Tannan Village was chosen, and we're focusing on the construction structures like the embankments, retaining walls, and box culverts. We choose 7 locations from these 2 villages as shown on the map. And from the literature review, we found that there's lots of application of using thermal images, most of them focusing on the temperature difference whenever there's water present. So we can find out that there's a hidden water body behind the walls, or we can find out the cracks because of the temperature difference. And also we find out there's a case using the thermal image to help inspecting the defects of the concrete along a very old bridges. So in these studies, we try to find out the defects of the concrete structures. So the first step, we need to determine the locations, as I present you in the previous slides. So we check out the Google Earth before we go outdoors, and then we try to find out any documents related to the locations. And we also need to determine the timing of taking the operations by considering the weather forecast as well as the routes of the traffic. Then we need to apply for the UAV permission in Taiwan. Then we will design our flight path, try to cover the whole area as complete as possible. Then we will take in photos. When we take in the photos, we take in 2 types of the photos together. One is the original or the general RGB photos. Another one is the thermal images. So we take out the thermal images and we run the image processing by the computer. We will highlight the thermal image, and then we can find the difference of the temperature. Then based on the thermal image processing, we can perform initial analysis about the images. And when we're talking about the image processing, we're using the commercial program FLIR to help us to do the jobs. There are 6 different types of highlighting the thermal images. In this pilot study, we choose the iron color set to highlight the thermal images. So our first test run was conducted on February and March 2021. And we choose the 7 locations and at the 2 townships. So we control our UAV at the altitude of the 10 meters and manually control to carry our thermographic camera and taking photos. Here are the examples of the photos from 6 locations. So from this slide, location 1 and 2 are check dams. And from the thermal image below, we can clearly find there's a temperature difference where there probably there's a water seepage or probably there's a defect on the surface. And on the location 3 is the photo of the embankment. We can clearly find there's a possible location of the cracks along the embankment surface. So for these 3 photos, location 5, 6, and 7, they are check dams, and we can highlight those location based on the thermal image. We found that there's a holes and also some gaps between the structural surface, and also there's some something different, irregular lines, patterns on the surface of the concrete. So let's take a close look and to try to summarize the findings of the photos. So For the street name in the photos, we noticed that there's possible cracks development on the surface of the concrete. We will also find that there are probably another different types of the defects on the surface of the concrete. So the thermal image can tell us additional information about the defects. So when we compare the RGB photos with the thermal image, we can easily find out the difference based on the temperature difference. Another close look is on the embankment. So from these photos, we notice there's a holes at the bottom of the embankment, and thermal image also shows a clear, dark colors over there. And those are the coring holes used for material testing. And the location from the photo, number 2 and number 3, are the irregular linear patterns, which we think that could be a suspected cracks development. But we need a further validation. Sometimes the dark color or the irregular linear patterns not necessarily mean to the cracks. So we need to categorize the findings after the image processing. So for our initial stage, we have several conclusions. We found that the thermal image can potentially capture the defects, holes, and the suspected cracks on the surface of the hydraulic concrete structures. And through the comparison of the thermal image and RGB image, we can identify the location of the cracks. And we want to identify the identification of the cracks into a database. So we need more photos and we need samples to clearly highlight the cracks locations. And also we found that we can use the linear patterns. Sometimes the darker linear patterns appear in the bright regions may represent some defects on the concrete surface. So our next steps will include, we will extend our photos. So we will check out at more regions, at more carriers. And we also want to consider the influence of the light conditions. For example, the daytime, or during the noon, or after the sunset. We want to take the photos at a different time of the day, and to compare the images, the thermal image difference between from the different shooting times. And our final goal is try to establish a thermal image database for later AI training, and then can help us to identify the potential defects or cracks automatically. So this is our today's talk about applying thermal image, and also how to use the UAV to help us to do the inspection works. Thank you very much for your attention. If you have any question, you can contact me through the email. Thank you.
Hello everyone, I'm Simon Chen. I'm from the Department of Land Management, Feng University. Today I want to show my topic is about applying the blockchain technology in the post-pandemic era. And I especially want to introduce the experience of the development of online contract signing and the login in Taiwan. I think that topic is very important because right now, during the pandemic, we just require everyone have to do the remote working or the remote online contract sign and login. So I think the technology property is quite important, and at least technology must use the blockchain to make sure data security and its conveniency. So I think that today my show is about my presentation. You can see before the pandemic, the tsunami of the new tech just going very, very quickly and much more powerful in real estate industry. Therefore, you can see after the pandemic, the impact, I think, probably has been fastened and enlarged, because you can see it on the full panda to deliver our the meals. So we can see from the statistic the using of the Uber Eats or the food panda just increased very fastly during the pandemic. Also, we can see such kind of development trend in Amazon. Amazon right now, you can see they recruit lots of the new employees, and its goods to delivery also increases so rapidly. So we can see that in the Amazon. And also we can see that the remote working pattern right now, much of the company, they just have required their employees stay at home and to do their work. So right now we use a lot of the online meeting software like the Zoom or Teams or the Google Meet, which right now it just become the new normal. And we can see that everyone just quite familiar and quite get used to use the online meeting to finish their work or their group discussion. So that's just very interesting, the phenomenon that just maybe just pushed by the COVID-19. So they'll become a very interesting things, especially in East Asia, because everyone just know about in the East Asia, probably from Japan, China, Korea, and Taiwan. We just get used to use the seers to represent the person or company, the entity, to sign a contract. But if we have the seer, then we cannot do the remote, the working, because we have to get the seer to sign the contract and then we have to go through the physical contact. So in 2020, last year, the June 19, the Japan government therefore decided to abolish the usage of seers in contract because to prevent the physical contact to contain the COVID-19 spread, and that is so necessary step. So you can see that, and in China as well, we also decided to abolish the seers to represent the company. But I think in Taiwan, recently we just have such kind of very serious the pandemic, the COVID-19 just spread out all over the Taiwanese society. So we also have such kind of pressure to try to find a substitute to replace the traditional use, the seers. So I think probably the blockchain technology can do it. And how we can use the blockchain to substitute the seers, I will introduce the next, what is the blockchain and how to use this kind of technology to replace the seers. Okay, so we can use the blockchain technology to substitute the traditional use, the seers. But so, and in the first instance that we have to understand what is the blockchain. So we can see there are 5 the key elements in the blockchain technology. One is the distribution, encryption, and the immutability, and the decentralization, and then of course the tokenization. So we can see in the first element that's very important in the blockchain technology, which is the encryption. Encryption is used one pair of key. We call it a public key and a private key. And we also use the asymmetry encryption in contrasting to the traditional symmetrical encryption, which is there is only one pair of the public key and the private key. There's only one pair of the public key and private key in the world. So we can use this kind of symmetrical encryption to increase our security, to make sure that our data will not be hacked. So that is one very important element. And the second very important is the use the distribution ledgers, which is the different distributed database, which is also become very, very difficult then to let a chance to hackers to steal the data. And then the third element, which is that because we can immune the hacker attack, and then we also have the very good encryption technology. Therefore, we can make sure the data which is stored in the database is immutability. no one cannot do any adjustment which is not get approved by the stakeholders. So we can make sure the data is right, and no one can do any private change. And of course, then we can make sure that everything is right. And therefore, then we can use some like technologies, such kind of the smart contract, and to do the automatically to enforce the contract. So we call it a smart contract and sale enforcement. And then finally, maybe we can use the token, just like the Bitcoin. The Bitcoin, then we can maybe Bitcoin just like the currency. Then we can just use the token just like the currency to strengthen our economy inside our blockchain, the society. So we can see there's this 5 very important key elements to build up the blockchain technology. Therefore, you can see lots of the scholars and applications use the blockchain into the property registry or in the real estate industry. So there is the property use. First, the level is use the blockchain recording, or use the smart contract to do the smart workflow, or use the blockchain to do the smart escrow. Blockchain registry, just like to replace the land registry. And also we use the token to represent our property right. So we can use the token, therefore we can easily to transform or deliver to do the property transaction. So therefore there was the different level of use the blockchain technology. So I think the very best application of blockchain is to use the blockchain to do the recording. Using is the technology which will make sure that every data is getting right. And of course, you can do it in remote or in an electronic way because we have the proper key and the private key to do it. So we can use that to substitute the seals, and then we can make sure the security function is much better than the traditional seals. So with our team, we also designed a system, we call it an e-contract in Taiwan, use the blockchain technology, and we try to substitute the seals during right now quite severe pandemic eruption today. And then I will introduce how to use the e-contract right now and how we design the e-contract in Taiwan, and try to make some help and assistance to help the society to get through this very unprecedented pandemic era in Taiwan. Okay, we designed a blockchain technology basis e-contract system, and when we try to make the process just very like what we have done today. And so we designed properly. We got 8 steps to complete the signing the contract and with the remote areas. So first step, you got the registration, and then you upload the contract, and then you decide which fields you want the people to sign, and then you can issue the contract, and then invite the people to sign the contract, and then therefore we will inscription, and then we will send it back to put on the box, and then we also will just make sure the contract finally is full of the signature that is necessary to do it. Then finally we just storage in the blockchain, ethereal, the blockchain system, to make sure that no one can really change the contract. So if you want to use our e-contract system, first step, of course, you have to do the registration and then log in. Then we can make sure that you got to qualify to use our system. When you finish the registration and then the login, of course, you have to type in your email address, and then we will send a message to make sure that your email account is available. And then you can registration and log in again. Then we will make sure your account is available. Then you can use the normal function that we designed in our e-contract system. Therefore, when you finish, you get qualified to do our membership. Then you can upload the contract. That's the very first step. You upload your contract. Then we require the contract that must become the PDF file. And then once you can upload the PDF file we design, then the number of files you can upload 5 at once. That's our maximum. You can upload the 5 files of PDF format. Then you set up, you can see the button. The button, therefore, the first one is you have designed which members you want to sign and where you want the people to sign. So you have to edit the people, and then you edit the right place, the right person to sign the contract. That is the step 3. You just arrange the person to sign and editing the signing field. Then you can go to the second step, which is once you decide the people, then we will require you to type in the people's email address, or you also have to type in the phone number. We just make sure the people are right. If you set up the people and you set up the right place you want the people to sign, then you finish the editing. Then you will do the next step, which is you are doing the ediction. Then you can send the contract to the right person. You can see that you just select the signer, add a signature cells. Then you can send the email to the right person. So when the people receive the mail, they will see a box. When you receive the mail, that our system will inform the person is you to sign the contract. Then you will see the invitation, and then we also get the secret, the password. When you type the password, and once the system has made sure that the password is right, then we will lead you to the right the address. And then when you go to the right address, then you have to type the password again. If you type the password is correct, then the contract will fully refill, and you can see the box, the place you need to sign, and then you can see that, and then you just sign your name on it. And then the next step, the contract, when the signing, of course you can use your handmade writing or use the typewriter to type. The both sides, the system all can accept the way how you sign the contract. And then finally, when you finish the sign the contract, then you can send it back to the system. And once the system have to receive all the process, and the contract then will form the complete contract. And then once the contract is finished, then we will storage your contract onto the Ethereum, the blockchain. Therefore, to make sure no one can really change the contract. And the generally case has been done. Then we finish the contract signing and logging and storage in the blockchain in a very safe place. Of course, we also set up some additional function, just like you can see the contract signing, the process. All the historical development we also get in our record. Also, you can check the historical the signing the process over each one. Of course, we also sign kind of a contract. Once you change your mind, you want to decline your contract. You also in your last minutes, you still can reject the contract signing, and of course, finally the contract will become failed. Then you can do it again, and we can reconsider each words in your contract again. So we also set up such kind of function to do the contract rewrite. So that's it's a very simple and very direct way to guide the people to use the blockchain-based technology to do the online contract signing and the logging. I think that will greatly help the people during this pandemic to do the new way to do the contract signing. And of course, I think that will substitute the traditional use, the seals, currently in Taiwan. And I think that after the pandemic, people still want to use that system because we don't need to travel, going through so many areas just to use our seat to finish the contract. This is so unnecessary. So I think that before the pandemic and post the pandemic, we always will get through a new era, and now must help by the new technology. Then we will go to a new way of the living pattern. I think the blockchain can do such kind of help during the pandemic and after the pandemic. I think that is my purpose to design the e-contract, to help the people to get through this pandemic and help them to go to the new era of doing our business. Thank you very much.
Hi, this is the Dean of the Construction and Development College in Feng University. Thank you for your joining our International Smart City Inc. Forum. I do believe in the past several hours, you enjoy all those nice speakers talk about all the issues, the application regarding the smart city. This is not the end of the discussion of the smart city in the Feng University. This is only a beginning. Hopefully, we'll be able to see all of you enjoy this kind of discussion and forum together very soon, somewhere in the world. Feng University, we're going to host another international Smart City e-forum very soon. See you again, and thank you.
you.